Hi everyone, welcome back to my channel. And in today's video, we're diving into the fascinating world of epidemiological modeling. Whether you're a budding researcher or just curious about how we predict disease spread, this guide will walk you through the basics in a simple and approachable way. Epidemiological models help us understand how diseases spread in populations, how they can be controlled, and even how future outbreaks might unfold. These models are essential tools in public health, especially in planning interventions and preparing for epidemics. So, what exactly is epidemiological modeling? In simple terms, it's the use of mathematical and statistical techniques to simulate the spread of diseases within a population. By using models, we can predict outcomes and assess the impact of different control measures, like vaccination or quarantine. There are several types of epidemiological models, but the most commonly used are deterministic models and stochastic models. Let's start with the basics of deterministic models. A popular deterministic model is the SIR model, which stands for susceptible, infected, and recovered. This model breaks a population into three groups: those who are susceptible to the disease, those who are currently infected, and those who have recovered. By adjusting parameters like transmission rate and recovery rate, we can simulate how a disease spreads and estimate things like peak infection rates and the duration of an outbreak. Let's break down how the SIR model works with a simple example. Imagine a community of 1,000 people. Initially, almost everyone is susceptible, but let's say one person is infected. The model will calculate how quickly the infection spreads based on certain parameters. Two key parameters influence the spread: the transmission rate, which represents how easily the disease spreads from person to person, and the recovery rate, which shows how quickly infected individuals recover and move into the recovered category. As time progresses, we see a typical epidemic curve. The number of infected individuals increases until it peaks, and then it declines as more people recover and fewer are left susceptible. By adjusting the parameters, researchers can simulate different scenarios, like the impact of interventions such as social distancing or increased vaccination coverage. While deterministic models are great for understanding overall trends, they assume that the same conditions will lead to the same outcomes every time. But in the real world, randomness plays a big role. That's where stochastic models come in. Stochastic models introduce randomness into the equation, meaning that even if the same conditions are applied, the outcomes can vary due to chance. These models are often used when dealing with small populations or rare diseases where random events can significantly impact outcomes. For example, in a small town, a single superspreader event might lead to a major outbreak, whereas in another scenario, the infection could fizzle out quickly. Stochastic models help capture that variability. So, how do these models help public health officials make decisions? Models allow us to simulate different scenarios and predict the potential outcomes of interventions. For example, during the COVID-19 pandemic, models were used to estimate the impact of lockdowns, mask mandates, and vaccination rollouts. By providing a range of possible outcomes, models help decision-makers choose the best course of action to protect the population. They're not perfect predictions, but they give us valuable insights into how diseases behave. Of course, no model is perfect. There are limitations to what epidemiological models can do. They rely on the accuracy of the data and assumptions we put into them. If the data is incomplete or the assumptions are unrealistic, the model's predictions may be off. That's why it's important to use models as part of a broader strategy that includes real-world data and expert judgment. Models are powerful tools, but they should always be used alongside other sources of information. In summary, epidemiological modeling is a critical part of understanding and controlling diseases in populations. From simple deterministic models like the SIR model to more complex stochastic approaches, these tools help us predict how diseases spread and evaluate potential interventions. Thanks for tuning in. If you found this video helpful, be sure to give it a thumbs up, subscribe to the channel, and hit the notification bell to stay updated with more content. Have any questions about epidemiological modeling? Drop them in the comments, and I'll be happy to answer.